Hello, students, and welcome back to another lesson. Today, we're going to learn about the scientific method. We're going to learn everything we need to know about the scientific method. We're going to walk through the essential steps and we're going to see how it is used in the real world and cover some common mistakes you should avoid if you need to use it for research purposes. Have you ever wondered why the bread you put in the toaster didn't toast, even though you're very sure you pressed the on button? Your first thought might be, why would my toaster toast? And then you might guess, maybe the outlet is broken. Believe it or not, in that moment, you have just started using the same problem solving steps that scientists use to understand every scientific law or theory. This process is what is called the scientific method, and it is the backbone of all scientific thinking. So, what is the scientific method and why is it important? The scientific method is a scientific way of learning about the world through observation, experimentation, and evidence based reasoning. It provides a logical framework that scientists use to ask questions, develop explanations, and test ideas. The reason why it's so important is that it helps us reduce biases and minimize errors and helps us distinguish fact from opinion. By ensuring that the experiments are objective and repeatable, the scientific method forms the very foundation for scientific discovery and technological advancement. So, the scientific method is pretty important. Let's look at a little bit of history that concerns the scientific method. The scientific method has existed for thousands of years. That means that all the great scientists we know today use them to create all their laws and theories. In ancient Greece, the philosopher Aristotle believed that we could understand nature through observation and logic, but he didn't test his ideas with experiments like we do today. Fast forward to the 10th century, and we have an Arab scientist named Al-Hazen. He used experiments to test his theories, especially in optics, making him one of the first persons to apply the true scientific method. During the scientific revolution of the 1500s and the 1600s, scientists started asking new questions about the world. Francis Bacon promoted inductive reasoning, that is, gathering data and drawing general conclusions, while Rene Descartes emphasized deductive reasoning and logical structure. Then came giants like Galileo Galilei, who used controlled experiments and telescopic observations to change old beliefs. And of course, we have Isaac Newton, who used experiments and math to unlock the laws of motion and gravity. By the 1800s, science was becoming more professional, and researchers like Robert Boyle and Charles Darwin conducted precise, repeatable experiments and shared their methods so others could verify them. Today, the scientific method has gone digital, from modeling climate change to discovering new medicines. Scientists even use computers, data, and teamwork around the globe. So whether you're testing mold on bread or launching a rocket, you are using a tested and tried method that has been shaped by centuries of human curiosity, logic, and discovery. Now that we know a little history, let's break down the actual steps of the scientific method and see how it works in action. While some sources might show 4 steps and others may show up to 8 steps, the core principles remain the same. And today we'll look through the most used steps, which are observation, a question, hypothesis, experimentation, analysis, and conclusion. So to do this more efficiently, we'll use a classic example. Let's say that you observe that your bread seems to get moldy faster in the summer than in the winter. We'll start from step one, observation and question. Everything begins with an observation. You notice something about the natural world that catches your attention. And in this case, the observation is that bread molds quickly in warm weather. And this leads you to ask a clear, testable question. Does temperature affect how fast bread molds? This will lead you to your next step, background research. Instead of starting from scratch, you can do a little homework. You gather existing knowledge by reading articles, books, or even previous studies. For example, you do a quick research and you find out that mold is a fungus that tends to grow faster in warm, humid environments. This leads you to your next step, forming a hypothesis. A hypothesis is an educated guess or a potential testable answer to your question. It is an explanation that you can test to see if it is correct. Good way to frame a hypothesis is to use the if dash then dash statement to make a clear prediction. Our hypothesis in this scenario would be if bread is kept in a warm environment, then it will mold faster than if it is kept in a cold environment. Then you move to the next step. You conduct a controlled experiment. And this is where you test your hypothesis. To make it a fair test, you must only change one factor at a time while keeping the other conditions the same. So in an experiment, there are three types of variables. So we have the independent variable, the dependent variable, and the controlled variable. The independent variable is the variable that you intentionally change to test its effect. And in our case, this would be temperature. Then we have the dependent variable. And this is the one you measure to see the outcome. Here, it would be the amount of mold growth. And then we have the controlled variable. And these are all the other factors that you must keep the same to ensure a fair test, like the type of bread, the moisture level, and the type of container. After considering all these variables, you place slices of bread in containers of three different temperatures. Let's say a cold fridge, a room temperature spot, and a warm area. Let's say your oven when it's off. And then this leads us to the next step. You analyze the data and draw a conclusion. Experiment is complete. You collect your measurements and analyze them. You can even use tables or graphs to organize the data and look for patterns. So, in this scenario, our analysis would be after 1 week, the bread in the warm container has the most mold, while the bread in the fridge has the least mold. And based on this analysis, you can then draw your conclusion. You can determine whether the data supports or refutes your hypothesis. Here, our conclusion is that higher temperatures do in fact accelerate mold growth, which supports our hypothesis. But if your hypothesis is wrong, your conclusion is still valuable. A result that doesn't support your hypothesis helps you rule out incorrect explanations and allows you to revise your hypothesis and test again. And this is a critical part of the scientific method process. And then finally, you can communicate your results. The final step is to share your findings. Scientists do this through reports, presentations, or publications so that others can evaluate or even replicate their work. A common misconception about the scientific method is that it is a rigid linear checklist, but in reality, it is an iterative process, a cycle, not a straight line. Scientists have often had to back up and repeat steps based on new information. The result of one experiment can become feedback that will improve the next round of questioning. So let's look at common mistakes to avoid when using the scientific method. First, don't assume that because two things happen at the same time, one of those things caused the other. This is confusing correlation with causation. Another common mistake that you should avoid is always be sure to only change one variable at a time. If you change both temperature and moisture level, for example, in our bread experiment, you won't be able to know which one is responsible for the result. So make sure you always test for temperature first, always then test for moisture level, test each variable at a time, a single variable at a time. And then lastly, never cherry pick your data. Don't be selective when picking your data. Ignoring results that don't support your hypothesis is bad science. Remember, even a no effect result is a valid result and an important finding. So if you want to try the scientific method for yourself, here are some fun questions you can try out. Which brand of detergent is best for laundry? And what happens to a plant when it grows indoors? These are simple experiments that you can practice your new skills on. So, congratulations, you have made it to the end of this video. Don't forget to subscribe, like, and share.